Today we are gonna do another question, which is the force F. The force F is given in terms of time t, time t, and displacement x. So, and is given by the equation F equals to A cos bx plus C sin dt. Find the dimension of d by b and a by c. So that's the question. We have to find the dimension of a by b and the dimension of c by d, which is this is a very good question. So to do this, first of all, let's write it. Go to another page. Write the equation, which is F equals to a cos bx plus c sin dt, where x and t are displacement and time respectively. So from the let's use principle of homogeneity. So from principle of homogeneity, we can say the dimension of f must be equal to the dimension of a cos bx, and which must be equal to the dimension of c sin dt. So we can do the first part, which is f must equal a cos bx, and since cos is a trigonometric function, this does not have a dimension, so the dimension of f must be equal to the dimension of a, and the dimension of f is mlt minus 2, since f is a force. So dimension of a is this. Now so let's write this formally in the end, which will be the dimension of a is mlt minus 2. So now let's take the second part, so second portion of the right hand side, which will give us c sin dt. So this is also from the principle of homogeneity, so let's write that as well. So from principle of homogeneity, we have this, and since sine is a trigonometric function, it's going to be dimensionless, so we can write that the dimension of force must be equal to the dimension of c. So the dimension of c will be the dimension of force, which is mlt minus 2. So we have the dimension of c, we have the dimension of a. Now with the now we need the dimension of b and d. So now if cos bx, so let me write the x, so cos bx and sin dt are dimensionless, then bx must be dimensionless too, since the term inside cos should be dimensionless, because it is measured in, it is an angle, so it will be measured in radian, since it will be measured in radian or degree, and which does not have a dimension, so we don't need to write the dimension. So it's going to be dimensionless, which is m0 l0 t0, or you can write 1. So here the dimension of x is l, so m0 l0 t0, hence the dimension of b will be l inverse. So we have the dimension of a, b, c. Now we need the dimension of d, and since dt is also inside a trigonometric function, so this dt will also be measured in radian or degree, which does not have a dimension. So we can write dt must be dimensionless. So let's we need to find the dimension of d. The dimension of t is time, m0 l0 t0, hence the dimension of D will be per time. So we have every single ingredient now that we need. So now let's find the answers that the question has asked us, which is, so now we first of all we need to find the dimension of D by B. So to find the dimension of this, let me use a shape. This is supposed to be a square bracket, don't mind the round brackets. So the dimension of D is per time, whereas the dimension of B is per length, which means D by B will lead us with length per time, which is the dimension needed. Now, for the second part, the dimension that has been asked is of A by C. So that if we need the dimension of this, so this is supposed to be square brackets, don't mind the round brackets, we will get the dimension of A is MLT minus 2. Similarly, the dimension of C is also MLT minus 2. So dividing them, you get nothing, which means the term is actually dimensionless. M0, L0, T0. So this is actually dimensionless. So now let's conclude the question. Therefore, dimension of D by B and A by C is LT minus 1 and M0, L0, T0 respectively. A by the dimension of A by C is actually it's dimensionless. So this was it for today's video. In the next video we are gonna do another question. Till then, bye bye.